its gravity is going to be changing because of the angle in the slope. So I thought that because of that, the acceleration would be continually varying as it moves up and down. So that's why I picked E, but that answer is wrong, and it's actually D, because it has the same acceleration as it moves up and down the plane. It's D because, for example, there's no like, how do I say it? It's like there's no like force like acting on it in the other direction other than force normal, of course, which is just going to be the same, but the acceleration is just going to be the same as it moves up or down. And some basic physics principles that you could use would be the notes, for example, that we did on the kinematics on the kinematics unit, and just, for example, one way that I wouldn't do this mistake again was probably not thinking about it in more of a dynamic sense, like in, for example, forces and stuff. I'll just I'll just think about it in a more of a like kinematic sense. All right, moving on. Question 2. I got this question wrong. Two objects are dropped from the same height. Object A falls through distance A at a time t, and object B falls through a distance dB during a time 2t. If air resistance is negligible, what is the relationship between dA and dB? So right here I drew a diagram. So this was A, this was B, and dA is t, and dB is 2t, t and 2t. So just, looking at the correlation, I could probably find that the relationship between dA and dB. So I would just probably set it up as like a proportion again, dA over t. And the answer is actually supposed to be A, by the way. I got this question wrong because I think I just set it up wrong. So dB over 2t, right? So what is dA? What is the relationship between dA and dB? So all of these, dA is equal to dB in some sort of way. So that's one way that you could start approaching it. Cancel out the t's. dB over 2, or over t actually. Oh no, over 2, yeah, is equal to dA. And that's what I did originally, but I didn't factor in the fact that I didn't factor in the fact that you have to multiply this by 1/2 again, and that makes it 1/4. And you do this because the time 2t that it takes for this object to fall for dB is actually also for dA. It's just dA has it over here. For example, both of these have to be 2t, or just actually, yeah, both of these times have to be 2t. It's just that one is lighter, so because of that, you multiply it by 2t, and these two cancels. These two t's cancel, and then this becomes 1/4 dB equals dA, and that's why A is the right answer. All right, moving on to 3. Right here, I messed up because I just didn't do derivatives, and I picked A, I think, because I did the third equation, which was wrong. If you did the derivatives, you could have easily gotten this question right. So the derivative of this would be A of t equals 6t minus 2, and then this becomes 0. So you get 6t minus 2, and then you just plug that into your calculator, and then you do 6 times 2, like this. 6 times 2 minus 2, which is 12, minus 2, which is 10. So it should be actually D right here. So that D is the right answer for number 3. It's just an easy question to miss. And by the way, both of these, the basic physics principles, the notes, they'll be at the end of the video because I can't really show them right here because this is a PDF. But I'll make sure to put them in, all the images at the end of the video. So stay tuned for that. All right. This was right. All right. So number 5, an object of mass 10 kilograms starts from rest at time and moves in a straight line for time t is greater than 0. The object's velocity as a function of time is given by this, where v is in meters per second, t is in seconds. How far does the object travel during the first 10 seconds of his motion? How far does the object travel? Okay, so that's talking about distance. So we're gonna have to find, that's velocity. So we have to find, it's gonna give us displacement, right? So one way we could approach this. By the way, I picked E, which is the wrong answer, and I picked this because, as you can see, the work here, 320 squared divided by 2 times 32 gives you 1600, which is wrong. And it's wrong because basically the fact that you find, this is the displacement, it's not the distance it travels. The displacement, okay, for example, the distance it traveled would be, in this case, 500, because I know the answer is D. But the displacement itself from point A to point B is going to be 1600, but you subtract 500 from that 1600, that gives you the answer, which is D. And the way you get the 500 is that you do or roughly 500-ish, because it's approximate. Anywho, so you first find the derivative of this, which gives you acceleration, which is going to be 6t plus 2. That's the derivative of it using the power rule. And because of that, you get at 10 seconds, so you get 6 times 10 plus 2, which is 62 meters per second squared. And then the velocity initial, we know, is going to be 0. Or, to be honest, because it says for time t is greater than 0, so we can't really use the velocity that's going to be 0. So we're going to let's just use t equals 1. So we'll just plug in v1 equals 2 times 1 plus 3 times 1 squared is 3 plus 2 is 5. So we do that. Yeah, it's 5. Okay, just making sure. And then v2 equals and then first you just multiply by 10, so 20 plus 100 times 320. And this is all meters per second, by the way, because it's velocity. And then you just do equation 5, which is what I did here, but I just didn't put in the right acceleration, as you can see. Alright, so you do 320 minus 5, both squared, all over 2 times 62. And then you get you get 825 for the duration of those 2 seconds, or I mean 10 seconds. And so that's 825. I guess you could use the t equals 0 here. So if you just do that quickly, instead of we'll just substitute in a 0 here. So it'll just be 320 squared over 2 times 62. And you get the same thing. Okay. Let me think. I know the answer is D, because I checked with a friend, and he told me the answer is D. But oh, I see. It's because it's 825 is the distance it travels from 0 to 10, right? But I think the acceleration might be wrong. Because of that, the answer is D. Okay. Yeah. All right. Moving on, question 6. Starting at time t equals 0, an object moves along a straight line with velocity in meters per second given by v of t equals 98 minus that. When it momentarily stops, its acceleration is going to be a 0 meters per second squared. No, that's wrong. Because when it momentarily stops, it's going to be going from like boom, 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 and then it just stops. It's going to be negative. So we can rule out A and E. And the reason I picked A, by the way, was because I just thought that, because it stops, it's going to be 0. But that's wrong. So it can't be A, it can't be E, because it has to be negative, because it's stopping after moving in like a positive direction. So it has to be negative. The acceleration, at least. Not, I don't know about velocity. So it has to be either B, C, or D. And B, C, or D. Okay, so negative 4.0 meters per second squared. Negative 9.8 meters per second squared. It can't be C, because that's just acceleration of gravity. So, can't be C. B, negative 4.0 meters per second squared. Oh, I guess you could just find, you could just do the derivative again. So you could just do negative 4t equals a of t. And then just look for when it's negative, or when it stops, I mean, negative 4x, right? You just go. So when it momentarily stops, it's acceleration. So this is acceleration. So just looking for 5, 6, 7. So at t equals 7. So it's going to be stopping, right? It's going to be stopping at t equals 7, momentarily at least. And then over there, can't be B. It's D. Because it's going to be stopping at 7 seconds right here. I already figured it out over here, the time at least. Now I don't know about the correct acceleration. I figured out that the time that it's going to be stopping at is 7 seconds. So plugging that into the derivative, which is negative 4x, or negative 4t in this case, equals a of t, or v prime t, either way. Plugging that in, negative 4 times 7 is negative 28, so it's D. Alright, moving on. Astronauts travel to another planet and wish to determine the accurate value. Oh, and drawing it all, that's just what I did, by the way. I just drew it all together over here, and I picked the answer D. Astronauts travel to another planet and wish to determine an accurate value for the acceleration due to gravity. They drop an object from the edge of a very cliff with a motion sensor to collect the data above, okay. If air resistance is negligible, the magnitude of the acceleration of the projectile is most nearly what? So it's just dropping. It's not really a projectile. Or they just drop it, right? They didn't throw it. Okay, so the magnitude of acceleration is what? So I guess we just find the the slope of this, right, will give you speed, and the slope of speed will give you acceleration. So just do that. That'll take too long. Oh, and the reason I got this question wrong was because I did it like this way, and I like just plugged in all of these, and then I took the, as you can see right here, actually I think I guessed on this question. Yeah, I definitely guessed on this question. Okay, yeah, that's wrong. Yeah. Okay, so they drop an object from the edge of a cliff. So that's the cliff. They drop it. Object right there. It's just dropping. That's G. It's gravity. Not our gravity, but that's just gravity. It's a very tall cliff with a motion sensor. Time 0.2. The velocity is going to be 13.13 meters per second. Let me check that with 12.9 minus 4.2. 0.7 minus 0.4. That's 29 meters per second squared. Or 29 meters per second. Okay, that's 29 meters per second. 29 minus 13.313 over 0.7 minus 0.4 or 0.1 actually, because right here we use that 0.1 value, right? It's 0.3. Actually, no, it would just be 0.3. Yeah, it would just be 0.3, all over 0.3. That's 52.9, and that's like rounded up, I guess. And because air resistance is negligible, it's going to be a little bit less, so it's going to be E, because you get 52.9 if you do that, if you just do what I did. For example, you take this, right, and then you take 29 minus 13, and by the way, I got 29 by doing the slope of this and this value, these two y's, and so you get 29, right? And then you just do 29.1 or 29 minus 13.13, and since these are intervals of 0.3, you just divide it all by 0.3, and you get 59 or 52.9 meters per second squared. That's the acceleration. Boom. It's going to be a little less, a little more, but that's basically what it is. So it's going to be, and 52.8 is the closest really, so it's going to be E for 7. All right, moving on. This one I had a lot of trouble with. I picked A because I thought the velocity as it fell, I thought it was going to be I thought it'd just be the same if the distance was doubled, but that's wrong, because it's going to be picking up. It's going to be, I thought it was going to be, the reason I thought the velocity was going to be the same was because of the fact that it's going to be, the acceleration would stay the same after a while, but that's like a completely wrong way of thinking, because, for example, you drop, something from the Empire State Building and it hits the ground. That's the velocity there is going to be way different than, for example, you just dropping, or the change in velocity there is going to be way different than the fact that if you just drop something off your desk, the change in velocity there is going to be way different. So that's the wrong way to think about it, and that's why A is wrong. So basic physics principles, are in the notes, the ball toss lab, stuff like that. So moving on, A is wrong. We know that for a fact. If distance was doubled, what would be the new speed? Okay, so over here, I think I tried doing the same thing. Couldn't really figure it out. So I did d over t. But you could just do v. You could just do, what's an equation? Equation 5, right? Vf squared equals vi squared minus 2a delta x. Just plug it in there. Vf squared stays the same, because we could just do v2 squared, doesn't matter, because over here I called it v2. Then v1 squared minus 2a, and then the distance was doubled, right? So that's going to be 2, or hold up. Yeah. It would be 2d. v2 squared minus v1 squared all over. And this would become 4AD. So let's just call it that. Negative 4AD. So divided by and v1, by the way, is 0, right? Yeah, so it's 0. So you get 4AD. Alright, so v squared equals 4AD. That's negative 2. Acceleration is going to be negative 9.8. So it's going to become positive anyway. So it's going to become 4AD, really, v squared. And then v equals 2AD. So that's what v2 is equal to. That's what v2 is equal to. Let's find v1. So v2 squared is equal to 2AD, right? Because these two are negative. The negatives cancel, because negative 9.8, negative 10, or whatever we want to call it. And square that, v2 is equal to 2 square root of 2AD. So yeah, it does double. Right, if distance was double, what would the new speed be? No, it wouldn't double. Because look, v2 equals square root 2AD. That's square root. That's not double. That's squared. So, I'm thinking... And what's 2 squared? Square root of 2, I mean. 1.4. Oh, it's b. It's b. Because of the calculations we just did here. So it's b. Alright, moving on. Again, right here, you could just do... the reason I got this wrong was because... I did 36 over 6. What? No. Think. Oh. I got the answer approximately to C. I think that the reason I picked I don't remember the reason I picked this. But I think it had to do something with these calculations here. I realized that 24, the whatever answer I was getting from these calculations was closer to 30 in my head than was to 24. So I think I just picked D. But it's probably wrong. The reason that's wrong is because they're asking for the velocity meters per second of an object. Oh, they're asking for the distance. Okay. Again, here you're supposed to know the integrals. I I didn't learn integrals yet in calculus, but when I was taking this test, uh, but I could have reviewed. I did review it, but it didn't stick in my head. So anyway, we could do this another way too. So there's another way. We could just find acceleration, which is going to be 12 t squared plus 2. That's the derivative of this. And then the derivative is 12 t squared plus 2. And then we just plug in for 1 here. Let's just plug it in. That's like 4 times 1, which is cubed. 4 times 1, which is 4, plus 2, which is 6. The velocity initial equals 6 meters per second. And the velocity final is going to be 4 times 2 cubed plus 2 times 2, just 36 meters per second. And then the acceleration in 1 second is going to be, what, 12 times 1, which is 12. It's going to be 14. Acceleration equals 14 meters per second squared. Okay, and then we just do VF squared. You just do equation 5. Alright, and then equation 5, V2 squared equals VI squared plus 2A delta X. Okay, so you just do V2 squared minus V1 squared all over 2A equals distance, which is V2 squared is 36 squared minus 6 squared all over 2 times acceleration, which is 14. And that should give you the distance. So I'm getting 45. I don't know if that's right or not. That's not right because that's not even an option. I'm pretty sure it's supposed to be C though. Yeah, the way I just did it was wrong. Completely disregard that. I'm pretty sure it's supposed to be C. Just disregard whatever I said. It's supposed to be C. I think I just picked the wrong answer because it was closer to 30. In my head at least. I'm not really sure. It was like some decimal, and I think it was closer in my head to 30, so I picked 30 over 24, but I'm pretty sure it's 24. Alright, moving on. That's right. So this one, I already can tell why I got this wrong. Is because I thought I was setting it up as a proportion, so these two immediately wrong. And I don't know why I thought these were wrong, because it's just a proportion. So anyway, that's wrong. That's wrong. That for sure. And then let's see. So magnitude of velocity, magnitude of displacement. So magnitude of displacement is going to be 32. It's not E. Displacement of 18 over t, which is 4. It's not 18, so it can't be that. Magnitude of velocity. Oh, 32. What are the odd magnitudes of the... Oh, for the first 3 seconds. Okay. So it moves 32 meters in 4 seconds. So in 3 seconds, it's going to be 32 times 3. So that's 24 meters. That's not right. You could do this. Uniform acceleration in the horizontal direction. Oh, we could just use an equation of time. It doesn't matter. VI equals, or VF equals VI plus AT. Velocity final, velocity initial, rest. So acceleration is accelerating uniformly. Acceleration times time. So that means it's D. Yep. Drawing that all together, it's D. Alright, moving on to question 15. This is wrong. 15 is wrong. Because A, it doesn't increase the entire interval. It just, right here, this is velocity. So that means it's displacement. So that means that the displacement is going negative, right? Meaning it's going to the left. Even though right here the velocity is increasing, it's the speed, which is distance, and is in the negative direction, is decreasing because the displacement is increasing. The distance is decreasing. So that means that speed is going to be negative in the first part, and then after that it's increasing, so it's E. We're moving on to 16, drawing it all together, it's E. And again, all of the basic physics principles will be at the end of the video, where I'll just put them up as images. That was right, okay. That's right, okay. Because that's like, I think that was a mistake. Because the grader told me that was a mistake. Or, I mean, not the grader, what am I saying? It's just a mistake because it's, on the actual paper, it's like scratched out. It's not a mistake. That's not wrong. Alright, this one, I know why I got this one wrong. I was being stupid. That's wrong. Because they do not weigh the same. There's no way. Come on. A freaking vacuum pump does not remove the freaking mass from a coin and a feather. It doesn't make their mass the same. It just makes the acceleration the same. Because there's no air in there to, like, you know. So it's going to be E. They hit the same at the same time because they have the same acceleration. It's E. Which is gravity. So it's E. It's like space because everything has the same. Anyway, alright, so it's E. Again, just do the derivative. For example, maximum positive velocity. So negative 18 t to the second plus 4 is equal to v of t. Then just plug that into your graphing calculator, or not even your graphing. Actually, yeah, it would help if you plug that into your graphing calculator. Did negative 18 times, or negative 18 x squared plus 4, and you just went to the table, or actually graph it first, and then you can see the maximum positive location, and then from there you see that it's the y-intercept, so it's going to be 4. It's going to be A, actually. The answer is going to be A here. Here, again, this is a dumb mistake. I don't know why I picked this. I guessed I was running. I don't know. I honestly don't know. I thought that this was increasing because of this, but it's actually not increasing. It's increasing up to here, and then it's decreasing, actually. But, anyway. Alright, so it's not increasing. It's actually decreasing, and it's in the positive. It's moving into the positive direction. Yeah, so it's B. Speed is decreasing, and it's moving into the direction that is positive. So it's B. 20 is B. Alright, so right here, so right here, Batman sitting in the Batmobile is watching Robin, who is 25 meters ahead. Honestly, I didn't know how to do this. I just really didn't know how to do this question. I don't know. It was like, I think this was something to do with the segmented motion diagram. I thought at the time anyway, and I really couldn't remember really anything on how to do this. But yeah, I don't really think. Yeah, I didn't know how to do this. I could tell from the work I just did right there. Anyway, how long does Batman take to catch up with Robin? All right, so velocity initial Batman, velocity final Batman is velocity final Batman. That's not 10. So, Batman sitting about 25 meters ahead, both are initially at rest. 2 meters per second. So, using Batman as the reference point, we can find Robin's velocity. So we can do so we have velocity initial. Let me make this thinner actually. We have velocity initial, which is 0 meters per second for Robin, and we have velocity, let me not write over there, let me write here, velocity initial, which is 0 meters per second, velocity final, which was we don't know velocity final, what am I saying, velocity initial, which is 0 meters per second. We know his acceleration, which is 2.0 meters per second squared. And then we know his delta x, which is 25.0 meters. Okay? So from this, we could obviously, already use this. Boom, it's 10 meters per second right there. We can find his final velocity, which is 10 meters per second squared. Or just 10 meters per second. So velocity final of Robin is going to be 10 meters per second. And then plugging that back in, we can get that t equals 10 divided by 3, which is 3.3. And that's 3.3 seconds that it takes him. So t equals 3.3 seconds for him to get to that final velocity of 10 meters per second. And then how long does it take Batman to catch up with Robin at an acceleration of that? So for Batman, his acceleration is going to be at 3.0 meters per second squared, and his initial velocity is going to be 0 meters per second. His delta x is going to be negative 25.0 meters per second. And then just doing the same thing, we get the square root of 0 plus 2 times acceleration, which is 3.0, times negative 25. Point zero. There's going to be no real answers. We could just make his acceleration negative, I guess. 3.0. Negative 3.0. That's going to give his velocity final to be 12.25 meters per second. Okay. Alright. So, how long does it take for him to catch up? Excuse me. So, how long is it going to take Batman to catch up to Robin? That's wrong, by the way. So it's just gonna be, again, it's just gonna be VI equals V, or VF, I mean VI plus AT, because Batman is not gonna have the same velocity final as Robin. That's just stupid. I don't know why I thought that. That cancels out. Acceleration, which is 3.0, yeah, times T, we don't know time, equals 12.47 divided by 3 divided by 3. 12.47 divided by 3 is 4.16 seconds. That's how long it'll take Batman to get reach Robin. How far does Batman go during that time? Well, he goes T equals, or how far does he go? Well, it's 12.47 minus 0 over 2 times 3. That's going to give you 2.0. Hold on. Oh, it's squared. My bad. I forgot to square it. That's going to be 25.92 meters. Boom. So the moment he catches up with Robin, the velocity is actually going to be 12.25. So it's going to be 12.25 meters per second. That's going to be the velocity of his car, and the velocity of Robin is going to be 10 meters per second. Boom. And again, my basic physics principles will be at the end of this, right now actually.